Good morning, everybody. I'm going to go ahead and do a little demonstration lab with you guys. We call it Weighing the Tiger. And I want to start by introducing our tiger right here. So this is our Lakewood tiger. And just want to say that there will be no tigers injured in this process today. So what we're going to do today is we're going to do some vector analysis, and we are going to find the weight of this tiger without knowing it beforehand, and then confirm it and see, does vector analysis lead us to the actual weight of the tiger? And we'll just wait and see. Okay, so getting started with everything today, I want to show you some of the tools that I'm going to be working with. So first thing is I've got this thing here, which is basically just a spring scale. So you can kind of notice with a spring scale, there's actually a spring inside here. You can kind of see it there. And when I go ahead and hold the spring scale up, I'm just going to look here and just see, is it balancing to 0? Okay. I'm just going to carefully eyeball it and say, yeah, it actually is balancing to 0. If it wasn't, I would need to balance this to 0 with a little screw mechanism on the top. Okay, pretty simple stuff. And what this does is when I pull something here, it tells me how much force is being pulled. Okay. So what I'll do then is I'm going to put these two spring scales, one here and one here, on this apparatus. And I'm going to go ahead and weigh my tiger. So I actually don't know the weight of my tiger right now. Let me go ahead and show you our little tiger here. Here he is. Okay. And but I'm going to go ahead and get a little extra weight. I've got a 1 kilogram weight here, and this will add to the weight of the actual tiger itself. I'm just going to put it inside our tiger today. All right. And I'm going to hang the tiger by this apparatus that I've set up. All right. Okay. Now, one thing to notice is that we have actually got some different angles going on here. So notice this angle here, it's actually steeper than this angle over here. Okay. And right now, the weight of the tiger itself is bearing down. Okay. And the only reason why the weight of the tiger bearing down doesn't cause the tiger to accelerate down is because there's a support force that's equal and opposite. Now, you might think that support force has to be straight up if the weight is straight down, but it's actually being taken up by these two strings right here. And because the angles are different, there's going to be different forces in each of these strings. And I can actually read these spring scales right here and see what those forces are. So let's stop there for a second. Okay, now what I'd like you to see is how I've gone ahead and put this tiger up on the smartboard in our class. Now, by doing this, I'm able to see the angles pretty well on that smartboard right there. And I can still read the weights in newtons of the tension in these two different cords right here. So I'm actually going to operate with the smartboard right now. So I'm going to go over to my computer station and show you what I'm doing here. Okay, so here's my two computers. And notice right here, I'm just going to go ahead and look over towards the board. But I'm just going to create some lines right here. And it's hard for you to see what I'm doing, but I'm going to go ahead and make a line here. And I'm going to go ahead and make a line here. Okay. And those two lines right there that I just put on the screen represent the angles that I have the tiger hanging from. And the other thing is I'm going to create a vertical line right here. And then with those, I'm going to use the protractor tool. I'm going to figure out what those angles are. So I'm going to do that right now with you. I'm going to grab the protractor tool. This is something that's in the smartboard program. And I'm going to go ahead and put it on here. Okay. And I'm going to figure out these angles. Now, the first angle that I see right here is 52 degrees. So I'm just going to go ahead and add that right in there for us to look at. It's going to be 52 degrees. All right. And the other angle, I'm going to flip my protractor around here. Okay. And that angle is 66 degrees. Okay, close that one there. Okay. All right, so I've established my angles right here. I got a 52-degree angle on the inside there and a 66-degree angle right here. Okay, now I'm going to post this on the slideshow too, so you can see this in a bit. So there's my two angles. Now the next thing I need to do is I need to read the angles coming on these strings right here. So I've got a side of this spring scale right here that actually reads in newtons, and so I'm going to find that right now. Got to come around to the other side to really look at it carefully there. And this one here is reading about 12 newtons. And the other one on my other side here, okay, is reading at about 8, 9, 10, 10.5. So we'll say 10.5 and 12. I'm going to add those in there, and then we're going to do a little math and see how this works out for us. Okay, so I went ahead and did the math on this whole thing, and what I was looking at was the fact that the Tiger has the weight going down, and those two strings just have their Y components of the tension aimed up. The X components are actually in a tug of war left and right, and they just cancel themselves out. So it's really just the Y component here that we're concerned about. And there's two Y components for each of the strings, and I add those two together. So I used a cosine function to do that with the angle and with the tension in the strings. And it turned out that my math worked out to 4.3 newtons for the left string and 7.4 newtons for the right string, just for their Y components. And that added up to 11.7 newtons. So according to vector analysis, this Tiger should weigh 11.7 newtons. So let's just take a quick look and see how that works. So I'm going to go ahead and pull the string off right here and just weigh the Tiger. And I'm just going to be able to look straight at it. And I'll kind of show you guys what's going on here so you can see. You can see I'm just weighing it straight on here. So it's just one string holding it now. And I'm looking at my numbers, and it looks to me it's just about 12, okay, just shy of 12. So it goes to show you that we did a pretty good job. This method of vector addition right here will get us the weight of the Tiger just like weighing it straight on would. Okay, so that's a lesson. You're going to see all the supporting notes to go along with that. There's also a PhET assignment that goes along with this activity too, and you're going to do this in your journal. So, all right, guys, enjoy yourselves. Have a great day.